Hi everyone, this is Jeff from Stratford Helms, and today we're going to talk about cross multiplication. Cross multiplication can be extremely convenient for you to use for any type of math that you might encounter when, as I tell my students, you know three things, but you don't know a fourth. And we'll get to that in a little bit. But first, let's explain what's on your screen. So on the right, we have a GradPoint window, and we happen to be in GED Prep Math in the quantitative folder. Lesson 7, ratios, rates, and proportions, and solving proportions. Now, we're just using this to illustrate some good examples of problems where cross multiplication can be a very efficient and very effective way to solve them. But you certainly don't have to be at this point, and you can certainly be past this point if you're going to go ahead and learn cross multiplication. So moving on from there, we have a paint window, and what paint lets me do is, write in a simulated pencil like this, and do things like say hi to everybody or obviously write math problems that you can see. Okay, and our third window is the TI Smart View software, which you've all received emails and or text about, and I will put a download link to that below in the video's description. If you don't happen to have a Ti-30XS Multiview, this calculator here that's pictured, which is the only calculator allowed on the GED, the HiSET, or the TASC, then you can certainly download this software to a PC or a Mac and work with it. So just as a quick example, what's 3 times 3? Well, let's take a look. 3, and you can see my last button press is always highlighted in red, so I hit a 3. See a 3 on the screen, times 3. And we're going to hit enter for equals 9. Perfect. Okay, so let's clear that out. Let's move our high so we have clean space to work. And let's get back over here to GradPoint. Okay, so we're right here. Okay. So let's see here. So if 3 onions weigh 0.75 pounds, how much do 10 onions weigh? Well, first let's illustrate an example of cross multiplication using simpler figures. So let's say we know 1/2. And we all understand a half. So we know 1/2. Okay, we have the fraction 1/2. But what we don't know is how many sixths 1/2 equals. So if I were to read this to you as the way this was written, if this was written as a proportion problem, kind of like this for cross multiplication, we would read it as 1/2 equals how many sixths? Or if one of something costs $2 and how many of something costs $6. That's another way to look at it. Okay, and we'll get into that all in a minute. So to practice our cross multiplication, what we're going to do is cross has to do with across from each other, like in an X pattern, like this. Okay, so if we look at this X pattern here, we see 1 and 6 are across from each other, and we're going to multiply those. Okay, so they get multiplied, they get a multiplication dot. Okay, now 2 and x are across from each other, but x is not a number, it's a variable, so that's going to get divided. Okay, so that means we're going to do 1 times 6 divided by 2. Take a look at our calculator. 1 times 6 divided by 2 equals 3, which means x equals 3. So in our example, if one thing costs $2, 3 things, x equals 3, cost $6. All right, so let's move down from there. Okay, now getting back to our example, here, if 3 onions weigh 0.75 pounds, how much do 10 onions weigh? Well, we know 3 things, 1, 2, 3, and we don't know a fourth. We don't know how much. So let's write this out. Okay, so we have onions and pounds. Okay, so we can either do onions over pounds, or we can do pounds over onions. It'll work out the same way, and I'll illustrate that to you right now. That takes a lot of the guesswork out of it. So we have O for onions over LB for pounds, LB for pounds over O for onions. So let's start. 3 onions weigh 0.75 pounds. So 3 onions weigh 0.75 0.75 pounds, or 3 onions weigh 0.75 pounds. Perfect. How much? Whenever you see how much, think X. Think a variable, X, N, Y, whatever you want to use. How much do 10 onions weigh? Well, how much do 10 onions weigh? Well, how many onions do we have? We have 10 onions. Okay, so on our O line, we put 10 for 10 onions. On our pounds line, how much is X? We don't know how much they weigh. Okay, same thing down here. On our pounds line, we don't know how much 10 onions weigh. Okay, now, these are going to be equivalent or equal to each other. Okay, so what we're going to do is we're going to look in that X pattern again. Okay, we're going to use that X pattern, and we're going to remember across. Okay, so if two numbers are across from each other, they get multiplied. Okay, and this guy, he's kind of the odd man out here because he's across from a variable, so we'll divide by that. We'll divide by 3. Okay, so let's try that. Over to the calculator. 0.75 times 10 divided by 3 equals 2.5. So X equals 2.5. Now, like I said, onions over pounds, pounds over onions, doesn't make any difference. Let's prove that. So here we have, again, another X pattern that we're looking at. The X pattern is number, number. Okay, if we have a number and a number across from each other like that, they're going to get multiplied. Okay, and the odd man out, the guy by himself right here, across from the variable, we're going to divide by that. Okay, so let's take a look there. Okay, so what do we have? We have 0.75. Over to the calculator. 0.75 times 10 divide by 3. 2.5. X equals 2.5. There we go. So whether we have onions over pounds or pounds over onions, as long as we keep things consistent, our X will mean the same thing, which is great. Takes a lot of the guesswork out. Okay, so let's take a look here. Have we solved this problem? Yes, we have. If 3 onions weigh 0.75 pounds, how much do 10 onions weigh? Not only did we solve it, we solved it twice. They weigh 2.5 pounds. Perfect. Okay, let's go on. So, postcards cost $2.45 for 5 cards. How much will 13 cards cost? Well, let's take a look at that. So we know 3 things. We know it's $2.45. That's the first thing. For 5 cards, that's the second thing. We know 13 cards. That's the third thing. But the fourth thing is how much. That's our X value. Okay, so let's take a look at that. So we're going to go money. That's a really ugly looking money sign, but we'll work with it. Over cards. Okay, so here we go. We know $2.45. And we know 5 cards. We also know 13 cards. But we don't know how much 13 cards cost. So again, we go in an X pattern. $2.45 or 2.45 times 13. Okay, that's our dot for times. Divided by 5 is going to give us our X. Okay, so over to the calculator. 2.45 times 13 divide by 5 equals your X, which is 6.37, which expressed in other words would be $6.37. So let's check our answer. Perfect, $6.37. Let's move on. Okay, so they're telling us to use mental math here, which could be appropriate for a GED or TASC student. In our case, working with a HiSET, as we do in Stratford, we would be defaulting to calculator. But certainly mental math, doing math by hand, doing math on the calculator, it always works the same way. Now here, doing these mentally, if we were looking at these mentally, these would be much more straight proportions and fraction problems where you would see that, okay, 12, 36, okay, well 3 times 12 is 36, so 3 times z is 21, and you'd set it up as an algebra problem. Same over here, okay, 10 and 40, well, okay, 4 times 10 is 40, 4 times 8 is, well, 4 times 8 is 32, so n equals 32. But never mind that. Like I said, we're not working on proportions right now, and we're not really necessarily working in, mental math. We're working with cross multiplication. So right now, they're giving us facts and figures that we could cross multiply. But let's move on to another word problem. Perfect. So here we have a problem that, in this case, deals with mental math, but that's okay. It's a multiple choice problem, and it is introduced by words, and that's a little bit more what we're looking for this exercise. So let's go over here to paint. So we have C over 10 equals 36 over 60. Okay. So what do we see? Well, I see numbers across from each other here, which means these numbers get multiplied. So we'll put our multiplication die here. Okay. And I see a variable, which in this case is C, across from a number here, which means this is the division sign here. Okay, so over to our calculator, okay, and we'll go ahead and put in 36 times 10 and divide that by 60. Enter. 6. C equals 6. And that makes a lot of sense because 6 times 10 is 60. 6 times C is 36. So 6 times 6 is 36. Great. Okay. Okay, now we're going to kind of bypass this cross products lesson and solve the proportions using cross products. We can take a look at that if we want to. Let's go ahead and jump up to similar figures. Okay. Now, similar figures will prove to be an interesting example as well because similar figures also use cross multiplication, and we'll get to apply it in a different way. Because basically there we were applying it with proportions, but we're going to show that we can apply it anytime we know 3 things and don't know a 4th. So I'm going to skip through this. You certainly read through this when you come to this lesson, but since we're not really dealing with, similar figures, we're dealing with cross multiplication and just using similar figures. That's why we're going to go ahead and skip through. So here we go. Okay. Example, finding a measure. Okay. Well, you can use proportions to find missing side lengths of similar polygons. Okay. So what this says is triangle ACT and triangle ODG are similar. Okay. And we can work on that later. But what that means is the triangle symbol with points A, C, and T. So that's this triangle. That's the little triangle. And triangle with points O, D, and G are similar. Now what similar means is same angles, so angle C and angle D would be equal. Angle A and angle O would be equal. Angle T and angle G would be equal. Same angles, but different side lengths. Okay, so in our case, because we know that these are similar, it means that they are able to be solved with cross multiplication, and I'll show you how. Okay, so let's take a look. So let's go to some clean scrap paper. Okay, here we go. So we want to find the value of x. Okay, and x is this side AC. Okay, and we can see in this particular figure that these triangles are oriented the same way, which means they're pointing the same way. They aren't always, but again, this isn't a similar figures lesson. This is about cross multiplication. So let's just get down to the meat of the lesson here. So side AC, on this small triangle is the same as side OD on this bigger triangle. Not equal, but it's similar, which means it's proportional, which means if 32 over 40 would equal x over 50, 24 over 30 would equal x over 50, etc. 40 over 32 would equal 50 over x, 30 over 24 would equal 50 over x, and we're going to take a look at that. Okay, so we're going to do this a little bit different. We're going to do L for little triangle and B for big triangle. And we're going to do it two different ways, again, to prove that it can be done. Okay, big over little. So we have little over big and big over little. So let's start. Now, for little over big, that means we start with triangle ACT for the little triangle. Okay, and we're going to start with the side that we don't know. Okay, and that's side X. Okay, so this side AC, okay, is going to be X next to the L for little over the corresponding side here, which is 50. And again, we're going to know three things, but we're not going to know a fourth. So let's pick one of these. I'm going to pick 32 on the little one and 40 on the big one. 32 for little and 40 for big. Okay, great. So we know three things, 1, 2, 3. We don't know a fourth. Perfect time for cross multiplication. So sometimes it can be a bit hidden, but in this case there are 6 different things here. 1, 2, 3, 4, 5, 6. But when you break it down, we're really only focused on 4 at a time. So let's use a different 4 for big and little. Okay, so big and little, we're going to start with what we don't know, which is X. Okay, but that goes next to the L for little. So in this case, it's going to go on the bottom. And what we do know is that corresponds to the 50 on the big one. Okay, now here's where we'll do it a little bit differently. Okay, instead of choosing these sides, let's choose these sides. So on the big triangle, this side's 30. B for big, right here. So we'll put 30. Okay, and we'll put that over the corresponding side on the little triangle, which is 24. Again, we know three things, and we don't know a fourth. Perfect time to cross multiply. So we have two different cross multiplication problems set up two different ways, little over big and big over little, using two different secondary reference points. Okay, so this is a really interesting example of how cross multiplication always works as long as you put the things in the right place. So here, let's look at the numbers that are across from each other in an X pattern. 50 and 32. Okay, and that'll get our multiplication dot. And then our number that's across in the variable gets our division sign. Okay, so let's start with that one. Over to the calculator. We have 50 times 32 divided by 40. 40. Okay, great. So X equals 40. Okay, now let's take a look at this bottom one. So we have 50 and 24, okay, they're numbers that are across from each other in an X pattern, which means they'll get a multiplication dot. We'll multiply those together, and then we'll divide by 30, because that one's across in the variable. Over to the calculator again, and we won't clear the screen. We'll keep those up there together so we can compare them, which is always an option. 24 times 50 divided by 30 equals 40. X equals 40. So in both examples, one using little over big, one using big over little, one using one set of corresponding sides from the other triangle, one using another set of corresponding sides from the other triangle, we got the same answer, X equals 40. So let's go through this. 40, perfect. Let's take a look at another problem. The trapezoids are similar, find X. Okay, so we'll kind of break this down a little bit. It can look a little overwhelming, but we'll look at this together. Okay, so let's get a clean piece of scrap paper. Okay, so we see X is here. Now, these trapezoids are facing different ways, okay? But just so we can work with simple numbers, this is going to be the big one, and this is going to be the little one. So let's start over here. Big, B for big, and L for little. Okay, so we're going to start with this bottom part, and we see that the trapezoid the slanted side on this one is on the right on the little one. It's on the left on the big one. So these are actually pointing different ways. But what's good to know is if we look at this side, the side opposite the slanted side, if we look at that here and here, it's pretty clear to see those are the same side. They're the side opposite the slanted side, and that's all we're going to look at. We're going to ignore all these other numbers and not get confused. Okay? So big over little. So big for this x is going to be this bottom NM, which is going to be the same as EF. It's going to be that bottom one. Okay? So big is x, okay, and little is 10. Okay. Now, what are we going to look at now? Well, I said we look at these here, right? This opposite the slanted side. Okay, here we go. Let's call it the height of the figure. So the height of the big one is 6. Height of the little one's 3. So here we go. In our x pattern, across from each other, 10 and 6, get the multiplication dot. 3 gets your division sign because it's across from the variable. We go over to the calculator. 10 times 6. Divide by 3. 20. So x equals 20. So we knew 3 things. We knew 1, 2, 3 things. We didn't know a fourth. So the base of this trapezoid is going to be 20. Let's check it out. Perfect, 20. Okay. Now, let's take a brief look at something that we can also use cross multiplication for, even though this does deserve a lesson on its own, and it will get one, which is measurement. Okay. So for measurement in the customary units, so you might call these imperial, standard, customary, American. There are many different names, casual, slang names, as well as, official names for this, but it's basically metric is, kilometers, meters, liters, grams. Customary is feet, inches, yards, pounds, cups, pints, etc. So let's check on customary units of measurement real quick. And we'll see if we can look at a little bit of this, because this is also a great platform to use cross multiplication. Okay, so let's do a simple problem or two here. Okay. And for this, like I said, this will warrant its own lesson, and we can look at that completely separately. Okay. So let's just real quick kind of fly through this. Okay, distance to Australia. Well, distance to Australia, that's not really going to work. Length of a pencil, I'm going to say inches. Okay, capacity of an eyedropper, fluid ounces. Length of a swimming pool, feet or yards. Weight of a baby, pounds. Okay, good. So let's just move through here, get to an example. Here we go. So let's look at this. Okay, how many quarts are in 14 pints? Okay, so if 2 pints equals 1 quart, then 14 pints equals 7 quarts. And the answer is 7 quarts. But let's go ahead and prove that. Okay, so we're going to say we know 3 things. We know 2 pints equals 1 quart, but we know our third thing is what do 14 pints equal, but we don't know what they equal. So we know 2 pints equals 1 quart, and we know 14 pints, but we don't know how many that equals. So we're going to pretend we don't see that 7 there for right now. So let's set that one up over here. Clean piece of scrap paper. So we can go pints over quarts or quarts over pints. Let's go pints over quarts. So we know that 2 pints equals 1 quart. We also know that we're trying to find out how many quarts 14 pints equals. So we don't know how many quarts 14 pints equals. That's our variable. But we know we have 14 pints, 1 quart, and 2 pints. So 2 pints equals 1 quart, 14 pints equals how many quarts? There we go. We know 1, 2, 3 things. We don't know a fourth. Time to cross multiply. Number across from number in an X pattern gets the multiplication dot. And we're going to divide by the 2 because the 2 is across from the variable in an X pattern. So here we go over to the calculator. 1, times 14 divided by 2 equals 7. Perfect. X equals 7. And that agrees with what we see here, 7 quarts. How many quarts are in 14 pints? 7 quarts. Great. So 3 quarts equals how many gallons? Now, like I said, this isn't a lesson in measurement. It's a lesson in cross multiplication. So I'll just tell you that 4 quarts equal 1 gallon. Okay, so now we know 3 things and we don't know a fourth. We know that 4 quarts equal 1 gallon, and we know 3 quarts, but we don't know how many gallons that equals. So let's move over here, okay? So we know we'll go quarts over gallon or gallon over quarts. Let's go quarts over gallons, okay? There we go. So if we know 4 quarts equals 1 gallon, and we know that we have 3 quarts, but we don't know how many gallons that equals, this is how we would set our problem up. 4 quarts equals 1 gallon. 3 quarts equals how many gallons, or X gallons. And here we go. In an X pattern, 1 and 3 with a multiplication dot. And 4 and X doesn't work, so we divide that. Okay, there we go. Over to our calculator. 1 times 3, divide by 4, 0.75. So X equals 0.75. And in this case, we're going to have to get specific because it says 3 quarts equals how many gallons? Well, 3 quarts equals X gallons. X equals 0.75. So 3 quarts equals 0.75 gallons. These happen to all be in fractions. So we'll jump ahead again on another lesson and we'll just go ahead and convert this to a fraction. So we can do that one of 2 ways. We can hit our second key, and up here, the second key puts you in the green. So the green key, second, puts you in the green, which is above the regular buttons with the white font. F to D, D to F. That means fraction to decimal or decimal to fraction. So we can hit that. Second, enter. So second, F to D, D to F, enter. 3 over 4, 3 quarters. Perfect. So X equals 0.75. X also equals 3 quarters. Let's look at a different way to figure that out. We can convert it back to a decimal. We can go second, fraction, decimal, decimal to fraction. Works both ways. Hit enter. And we're going to be back to 0.75. Now there's another way to do this. And that's using this button called the toggle button. Let's hit the toggle button. There we go. 3 quarters. So we're toggling between decimal and fraction. Decimal and fraction. Decimal and fraction. So if we go over here, 0.75 equals 3 quarters, and we're done. So that's a basic primer on cross multiplication. I hope it was helpful. I hope everyone's doing very well with their studies, and I look forward to seeing everyone back at school soon. Bye-bye.